Hello everyone, my name is Tom Lung and with the student ID of S3958304, and this is the video presentation for assignment 2 of the Cloud Foundations course at RMIT University. So the tasks that are going to be covered in this video are creating a virtual private cloud or VPC, then configuring a static website 3 different ways. The first one is using an EC2 instance, then we're going to use the S3, and then lastly we're going to use Elastic Beanstalk. Then we're going to configure auto-scaling and load balancing for our static website. Finally, we're going to configure a dynamic website with EC2 and RDS, which is AWS's relational database service. And finally, I'm going to showcase the overall system architecture. Okay, now we're going to tackle task A, which is creating a VPC. So the requirements are we're going to configure it with 2 availability zones. And per availability zone, we're going to configure 1 public and 1 private subnet. Then we're going to associate route tables to the subnets, and we are not allowed to use the VPC wizard, which is the selection of VPC and more in the AWS UI. Alright, so here we are at the AWS user interface where we interact with AWS resources. So the first task is to create a virtual private cloud. So I'll just use it on the search bar right here. We'll go into VPC and I'll create a VPC. So let's say VPC only. I'll create a name. My student ID with the IPv4 CIDR. I'll choose 1016 so we get a wide range of IPs for our subnets. We'll choose no to the IPv6 CIDR block. And these all look good, so I'll create a VPC. Alright, after we're done, we're going to configure our subnets. So as per the specification, we're going to create 1 public subnet and 1 private subnet for 2 availability zones. So we'll get started on that right now. So we'll name our first subnet a public one, so we'll make public subnet 1, and we'll configure it in the US East 1A availability zone. I'll give it a subnet of /24 so we get access to 256 IPs right here. We can add 1 more. Let's make 4. Okay, the next one will be a private subnet, so one in the same availability zone. Okay, we'll give it a different subnet CIDR block, and then we'll configure it for our second availability zone, which is in US East 1B. Give it a 256 IP subnet, and the same for the private. Same availability zone as the 2 one. Alright, so these subnets should be created. And okay, so currently these all 4 of these subnets are the same because we haven't associated any route tables to it or haven't attached any internet gateways. So we'll have to create an internet gateway for our resources to access the internet. We'll just name it IGW, and then we'll attach it to our VPC. There you go. Then we'll configure our route tables to attach it to our subnets. So I'll call it route table public. We'll attach it to our VPC, and then we will edit the routes. We'll add a route. This means that we can access it from anywhere, and we can see our configured internet gateway right here. Alright, we'll save changes, and we can attach this route table to our subnets. So public subnet 1 and public subnet 2. So all resources in these subnets will be able to access the internet. Next, we'll create a route table for our private subnets. So the same process as before. We'll name it. We'll have to select our VPC, and we leave it as it is right now. So in the future, if we want to have access to the internet for our private subnet resources, we can either attach a NAT gateway or we can create a NAT instance. So any traffic that we in our private resources that we want to connect to the internet, it will be forwarded to the NAT gateway or instance to allow it to connect to the internet. But it is not covered in the scope of this assignment, so we'll just leave it as it is right now. And we will associate it with our two private subnets. Okay, so we can see an overview of our VPC. We can see that we have created subnets in two availability zones. US East 1A, US East 1B. Each of AZ has a public subnet and a private subnet routed to a route table, a private route table, and a public route table, which is connected to an internet gateway. And that marks the end of task A. For the references that I used in creating completing task A, I used the lab 2 in the Cloud Foundations AWS Academy course. Even though we use the VPC in more option, the flow of it is very similar, but we can also use the AWS docs right here in creating a VPC, and after that we can create a subnet and configure the route tables. So following these 4 documents, I was able to complete task A. Alright, we'll now move on to task B, which is configuring a static website with EC2. The main requirements for this task is to first configure a security group with HTTP and SSH access. Then we'll use the source code that is provided in the assignment brief to start up our static website. And we will have to ensure that the public IP of the instance is permanent, so it is not changed when the instance is stopped and then restarted. Alright, we are back at the AWS UI homepage, and we're going to configure a static website with EC2. So we'll just type EC2 into the search bar. We read to the EC2 dashboard, and we'll spin up an instance. So we'll just launch instance. Gonna take you to this nice UI. I'm gonna name it our static website. Alright, I'm gonna choose the default Linux AMI with the default T2 micro instance, which is more than enough for our static website. I'm gonna choose the provided key pair, and we are going to put it in our VPC in our public subnet. We're going to assign a public IP. We're gonna auto assign it right now, but later we're going to assign a permanent IP to it later. We're going to create a security group. We're going to name it web security group, and our description is security group for HTTP and SSH. Okay, so SSH is already enabled. And then we are going to configure HTTP access with the port 80 from everywhere. So HTTP and SSH. That creates our security group. Gonna default storage, and we'll pass in a user data, which is basically a script that is gonna run when the instance boots up. So a bit of an explanation on how this script works. It's going to install the Apache web server and PHP. It's going to download the files provided in the assignment. It's going to unzip that, and it's going to move it to this directory right here, which will enable our instance to serve our static content. It's going to turn on right now. We can launch the instance once we're happy with all of the details. All right, let's launch the instance. Alright, so our server has booted up, and we can access it via the internet with our public IP address. Here we go, and we can see our static website is up and running. Now we're using a public IPv4 address that is not permanent, so I'll show you how to attach an elastic IP, which is going to be permanent from Amazon's pool of IPv4 addresses, and we'll allocate one IP address right here. We'll give it a name, let's say static website, and we are going to associate this IP address with our static website. Alright, we can associate it. So now, even if we restart our Learner Lab session, this IPv4 address will be permanent. And I can show you that. Here we go. We're able to access this using our permanent elastic IP. To complete task B, I actually used the same lab for building a VPC and launching a web server. We have this task 4, which is very similar to what we did in task B. Difference is it was pretty similar to everything we did, but there was a task that specified us to use an elastic IP. So I used this document file to create and associate the elastic IP with the EC2 instance. Alright, we are now going to do task C, which is deploying the same static website as before, but this time we're going to use S3, which is Amazon's simple storage service. So the task that we're going to do for this task is to create an S3 bucket. We're going to configure it for hosting our static website, and then we're going to enable public access with a few policies. Alright, we will now get started with task 3. So as said before, we're going to host a static website using S3. Going to navigate to S3 right here, and we are going to create a S3 bucket. I'm going to name the bucket as static website bucket. Alright, we're gonna leave everything default except for blocking public access, which we don't want. Alright, leave this all as defaults. Alright, we can create the bucket, and we have our general purpose bucket created. Now we are going to configure it for static website hosting. We can head over to the properties tab. We're going to enable static website hosting. Okay, our index document is index.html, and we should be all good to save changes. And then we will add a few policies for us to be able to enable public access. Just change this name to alright, should be good. Alright, once we have configured our S3 bucket to host the static website, we're going to upload the files that are needed to host this website. So we'll add the HTML file, and then we'll add the CSS folder, and then we'll add all of the images. Alright, and we'll click on upload. Gonna wait for these files to upload. Alright, our upload has succeeded, and we can get our endpoint from the properties section. So static website hosting, we can go to this endpoint right here, and we can see our website has been successfully deployed on the static website bucket endpoint. To complete task C, which is to host in static website using Amazon S3, I actually just used the tutorial on the AWS docs to create this bucket. So as you can see, it was pretty similar to what we did. We created a bucket, we enabled static website hosting, we edited the block public access settings, and then adding a public bucket policy for it to work. And for the documents, we already had the documents from our zip file, so it is just a matter of putting the files up there and all should be good. So yeah, I just used this tutorial file. Alright, for task D, we are again going to deploy the same static website as before, but now we're going to use Elastic Beanstalk, which is a deployment service that streamlines everything that we have done so far and makes it a lot more simpler without the administrative overhead that we have configured before. We are back in the AWS UI and we will search for the Elastic Beanstalk service. Alright, here we go. We'll create an application. It is a web server environment. Okay, we'll give it a name. Static website EBP for Elastic Beanstalk, and we'll give it the same environment name. We'll leave the domain blank for auto-generated. Choose a platform, Tomcat. We'll leave everything as default. We'll upload our code. We'll give version label, we'll give it a 1.0. We'll upload our zipped static website file as we've done before. Alright, we'll give it a single instance, leave everything as default. Next, give it the lab role using the Focky EC2 pair, and we use the lab instance profile. Next, to set it up in our VPC that we've created before. We are going to enable it in our public subnets. We'll assign it a public IP address. This is a static website, so we don't have a database. Go to next. And we'll leave off this as default. Actually, we'll skip to review because we've done all of our configuration. And we can review our configuration right here. Right, our application code is uploaded. Alright, we can submit. Alright, so after a couple of minutes, our application environment has been successfully launched. So you can see in the events tab here what it did. So it created an S3 bucket for environment data, it created a security group, it created an Elastic IP, it launched EC2 instances, and it successfully launched our environment. And we can click on the domain of our website right here to see that our website has been hosted. It was pretty easy to do that, just a couple clicks and a few minutes, and our website is up and running. For task D, which is to host a static website using Elastic Beanstalk, even though it was pretty intuitive using the Elastic Beanstalk UI, I actually found this video to be pretty useful to get up to speed with what is happening. So even though the UI has changed, the flow of creating a website is very similar. So I just followed this video to upload the application file to Elastic Beanstalk as I did in task D before. So yeah, this is my reference for task D. Alright, we now move on to task E, which is setting up auto-scaling and load balancing. It is to ensure that when our application gets a lot of traffic, we can create new EC2 instances to combat that traffic, and we set up a load balancer to ensure that the traffic is evenly distributed across several EC2 instances that we have set up. So the subtask for this task is to create an auto-scaling group. We will then create launch templates. So each time a auto-scaling kicks in, it knows what we want to configure the EC2 instance with. And then we will configure the scaling policy, how we will determine when to scale up or down. And then finally, we will create a load balancer to balance the load between the EC2 instances in our auto-scaling group. Alright, we are back in the AWS UI. We are now going to create the auto-scaling group and the load balancer. First up, we're going to create the load balancer because firstly, takes the longest to boot up, and also it will serve as the base for our setting up later with the auto-scaling group. Since we have to attach it to a target group, we're going to attach the auto-scaling group to a target group. So the Elastic Load Balancer knows where to where to route the traffic to. We're going to name our Elastic Load Balancer. Here you go. It is internet facing IPv4. We're going to put it in our VPC and put it into 2 availability zones to our public subnets. We're going to choose one security group, which is the web security group we created earlier. We're going to create a target group. It's with EC2 instances. Okay. Target group. Static website. Put it in our VPC. Checks everything default. Okay. Target group. We don't have any instances available right now, so we're just going to create our target group and leave it there. We're going to attach our auto-scaling group later on. Going to forward it to our target group. Alright, everything seems to be good. We'll create a load balancer. Alright, well, as we waited to boot up, we will create our auto-scaling group. Okay, we'll name it. We will, as our name, we will have to configure it with a launch template, which means that every time a EC2 instance is boot up, it will use this template to know how to configure the EC2 instance. Okay, we'll name it our user ID and launched template static website. Say a launch template for a static website. Right. So the setup process is basically what we do with our EC2 instance before. Configure the instance type, the key pair login, and we will configure it with our security group. We'll also paste in the user data, so the application code is readily available and started up as we did with our EC2 instance in task B. Alright, we will now create the launch template. We'll go back to our auto-scaling group and we will attach it to our auto-scaling group. Alright, we'll put it in our VPC and we'll attach it to our public subnets. Alright. Next, we will attach it to an existing load balancer, the one that we created before. We will attach our auto-scaling group to the target group that we created. And everything seems to be looking good. Here we will configure our scaling policy. So let's say our desired capacity is 2 and our max capacity is 3. We will add a scaling policy, so we'll put it as default right now. So the average CPU utilization, we'll put it at 50. We'll leave everything as default. Here we can review. So there's our launch template. Well, this is our name, our launch template. Put in our VPC, available at 2 subnets. We'll attach it to our load balancer, and this is a target group. Everything seems to be good. We'll create the auto-scaling group. We'll now wait for the auto-scaling group to be created. And later on, we'll move to our load balancer. And once we access this URL, everything should be good. So here we go. It is connected to a target group which has instances into it, which means our auto-scaling group is booting up. We'll come back once everything is booted up. Alright, so our auto-scaling group is up and running with 2 instances. We can check over to the load balancer, and we can see that the target group has been populated with the 2 instances in that auto-scaling group, and we can head on over to this URL, actually copy it, and I will paste it here to see that our website is up and running and configured with the Elastic Load Balancer. For task E, I used this article that I found on Google. It's actually in Vietnamese, but I translated it into English for the purposes of this video. It pretty much walked me through what to do in configuring a load balancer and an auto-scaling group. It's very similar to what I did. So creating a target group, creating a load balancer, configuring it to match our needs, and then we'll create an image and a template for auto-scaling, and then we'll attach it to the target group as we did right here, and doing the policies and everything. So yeah, I found this article to be very helpful. It's actually in Vietnamese, so I'll show the original. Here you go. And this was my reference for the load balancing and auto-scaling task. Okay, so we are up to our penultimate task, task F, which is to create a dynamic website. The subtask is to create an EC2 web server, so same as what we did before basically, but the difference is now we are going to create an RDS database or relational database service. We'll have to configure the database credentials, which will enable us to connect our website to the database so we can do operations related to it. Alright, we are back in the AWS UI, and we'll get started on task F, which is to create a dynamic website. To do that, I'll first launch an EC2 instance that contains our application, and then we will create a RDS, which is a MySQL instance. We'll choose the 2 AMI, the Linux 2 AMI, as per the specification in the requirements. The default instance type is okay. Choose the key. We'll put it in our VPC in the public 2 subnets, as the public 1 subnet is pretty crowded already. We'll put the web security group as before. We'll have to choose the lab instance profile for our IAM roles, so it can pull the metadata from the AWS AMI. And for this application, I actually found that we need to put the v1 and v2 metadata version for the application to work. And now I'll paste in the user data file. So as you can see, it's very similar to what we did in task B, but the difference is we have to install PHP for our app to work, since this is a PHP app, and instead of the static website as before, we'll do the inventory app. Alright, seems like everything is looking good, and I'll proceed to launch the instance. After the instance has been successfully launched, we'll try to access this website to see if everything is working as we intended. Alright, it seems that our our instance has been successfully launched, and we'll now try to access it. Okay. HTTP site. Right, seems like everything is working fine, and we have the ability to set our endpoints. I'll just clear this. This is the test run that I did before. Okay, since our application is not working, but we need these credentials for it to be able to access our database. So we'll get started on doing that right now. First, we'll have to create a database security group for our database, so that it only gives access to the instances that we want to. So we'll name this database SG, security group. Secure description, we'll name it security group for database. We'll put it in our VPC. We'll add a inbound rule. Since we're booting up a MySQL instance, we'll choose this port range, and the source will only allow inbound traffic from our web security group. And outbound rules, it seems to be okay. We'll just leave it as default, and then we'll create a security group. Now security group has been created successfully. We will now get started on creating our database. We'll first create a subnet group for our RDS deployment to know which subnets it is allowed to place the deployments in. We'll name this subnet group RDS. Give it a nice description. Put it in our VPC. We'll want both availability zones, and we'll put it in our private subnets, since we don't want to place our database in a public subnet. And now our subnet group has been created, and we'll get started on creating a database. And click on the create database, and we'll choose standard create. We want a MySQL instance, and these defaults are okay. We'll put dev test, and we'll put it in we'll deploy 2 instances for it to enable the multi-AZ deployments, which makes sure that our database is more redundant. And we can configure a name for our database. We'll just put it in our SID database. Okay, master username. We'll put in a password. I'll say task f-password. Seems to be strong. That's good. All right. For instance configuration, since this is a demonstration, I'll just put the smallest instance available, and I'll put this into minimum. Put the allocated storage into minimum, since we don't need that much storage for our demonstration. We'll put it in our VPC, and the subnet group that we created has already been selected for us, so that's good. All right, so no public access. We'll choose security group. We'll put for VPC security firewall to allow access to our database. We'll put WebSG. For our VPC security group, we'll choose the security group that we created before, this one, DBSG. And everything seems okay for now. We'll disable monitoring so we can save our cost. Initial database name, we'll just database. We'll just name it task F database. We'll disable backups, but it's we should enable this in production, but since this is a demonstration only, we'll disable this so we can save on cost. And everything seems to be good, so I'll get started on creating this database. All right. Once our database is created, we'll put in the credentials for our web application for it to connect to our database, and we can get started on working on it. Alright, it seems like our database has been created, so we'll get started on putting the correct credentials on our website so it can connect to our database. Okay, so our endpoint, we'll select the endpoint from here. Apologies. Okay, the database name, the username is admin, and the password was taskf password. It's good, should be good. All right, so we have successfully connected our database to our application, and we can use some features of the application like adding inventory, store, or put it in Ho Chi Minh. The item is Amazon Kindle to satisfy our AWS overlords. Quantity, we'll put good tea, and it's been saved into our database. We can also edit. So I want Amazon Kindle, I want Amazon Fire. Doesn't really make sense, but here we go. That's all good, and we can also delete it. And it seems like our application is working successfully. For task F, I actually just followed. It was very similar to Lab 5, which is to build a database server and interact with your database using an app. So it's pretty similar to what we did in task F. So creating a security group for the database, creating a subnet group, creating an instance. I just followed it and just tailored to our VPC and what we did, and interacting with the database. I think this application was pretty similar to what we did in task F. So yeah, just following this lab enabled me to do task F pretty efficiently and fast. Alright, we are now on to task G, which is to showcase the system architecture of what we created in the whole video. So to recap, we have created a virtual private cloud, or VPC, in the US East 1 region with services configured like I'll first talk about the subnets that we created. So we created 4 subnets across 2 availability zones. In the 1A region, the East 1A region, we created a public subnet and a private subnet with the corresponding CIDR block, as you can see right here. And also we replicated the same process in the second availability zone, which is East 1B. So we have a public subnet and a private subnet. Then we'll move on to, these public subnets are routed using a route table, which we have routed to a internet gateway, so the services can connect to the internet, and also enables the users to connect to our instances. For the private route table, it is currently set as default, but in the future, if we want, we can set up a NAT gateway or a NAT instance in the public subnets if we want to enable resources or create resources in the private subnets that we want it to connect to the internet. We'll move on to the EC2 instances, or the websites that we have created. First, we create a static website. We put it in public subnet 1, and we also created an elastic Beanstalk website, which is connected to a S3 bucket that it created by itself for it to store its configuration. We also hosted a static website using an S3 bucket, as we can see right here. We also created a auto-scaling group for it to host our static websites, as showcased right here, and we hooked the auto-scaling group to an elastic load balancer for it to distribute the load evenly between our 2 instances in case of high traffic instances. And finally, we created a dynamic website, which we put in public subnet 2, and we connected it to a RDS instance or RDS database that we placed in the private subnet 1 with its own security group, and we only allowed traffic from the web security group to route into this RDS instance. And that pretty much marks the whole system architecture that we have created throughout the video. So thank you for watching.